Hello friends, welcome to Learner's Planet. Friends, this is our third session for factorization, HCF and LCM. We'll also be covering a number related conceptual problems, divisibility concepts and basic algebraic formula and their application in this session. Okay, so let's begin this session. I hope you are having your paper and pen with you. Now let's see this problem. The HCF of two numbers is 8 and then which of the following can never be their LCM? Friends, we know that HCF should always be a factor of LCM. Okay, so definitely 8 is factor of 24, 56 and 48, but 8 is not a factor of 60. So 60 cannot be their LCM. Okay. Now let's see this problem. Three different containers contain 496 liters, 403 liters and 713 liters of mixture of milk and water respectively. What biggest measure can measure all the different quantities exactly? That means we are looking for HCF of all these three numbers, that is 496, 403 and 713. Okay, so let's see how do we find out. 496, 403 and 713. Friends, we have discussed the division method to find out the HCF. In that case, we just divide. We take two numbers. Say in this case, suppose I take 496 and 403 and I keep on dividing till I get the remainder as 0. Okay. Now for the first division, I just write okay. So when 403 is divided by 93, we'll be getting some remainder. Okay, whatever the remainder is. Then we'll further divide 93 by that particular remainder and the process will be continued till we get the remainder as 0. So when we get the remainder as 0, in that particular operation, whatever the divisor, that will be the HCF of these two numbers, that is 496 and 403. Then whatever the HCF of these two numbers will get the HCF of that particular number and 713. Okay, so this is how the procedure of division to find out the HCF. Okay, but we'll be doing a smart work over here. Friends, division is actually repetition of subtractions. Okay, so what we do, we just try to subtract. Suppose I find out the difference of 496 and 403, which I am getting is 93. Now we just see in the option key whether there is any number which is factor of 93. That we can see over here, it is 31. So bright chances are there that 31 will be HCF of all these three numbers. Okay. Now we can randomly divide 713 by 31 to just see whether it gives the remainder as 0 or not. Okay. So let's divide 713 by 31. You'll be getting remainder as 0. Then definitely 31 is factor of 496, 403 and 713. Further, I would like to repeat that if we are getting the difference, in first step we are just finding out the difference between two numbers, and bright chances are there that whatever the remainder we are getting over here, our answer or our HCF will be definitely either same number or its factor. Okay friends, I hope you are clear with the method. Now in this problem, the maximum number of students, among them 1000 pens and 900 pencils, can be distributed in such a way that each student gets the same number of pens and same number of pencils. Further, we have to find out the HCF in this case. Now let's see how do we find it out. Let's find out the difference between 1001 and 910. It's actually 91. Now we have to see 91 is factor of 1001 and 910 both as well. So definitely 91 will be the HCF. No need to calculate. Now let's see this problem. A rectangular courtyard 3.78 meters long and 5.2 meters wide is to be paved exactly with square tiles. All of them are of same size. What is the largest size of the tile which could be used for this purpose? That means we have to find out the HCF. Friends, it is in meters. Let me convert into centimeters. So it will be 378 centimeters and it is 525 centimeters, since 100 centimeters is 1 meter. Okay. Now we have to find out, since we are making square tiles or we have to pave with square tiles, we should find out their HCF. Now what is the first step to find out HCF? Let's find out their difference. So it's 525 minus 378. It will be 15 minus 8, 7, 4 and 1. It's 147. Now bright chances are there that either 147 or any factor of 147 will be the HCF. Now look at the option. 14 cannot be right choice because 14 cannot be HCF of an odd number. I'm sorry, 14 cannot be factor of 525. Okay, and HCF must be, that is highest common factor, must be a factor of both of them. Okay, so 14 cannot be right choice. Similarly, 42 cannot be right choice. So we are left with 21. Now 21 is definitely a factor of 147. That is 21 into 7 is 147. So 21 will be the right choice. Else you can repeat the process till you get the final HCF. Okay. Now, in this question, we have to find out the greatest number that will divide 43, 91 and 183 so as to leave the same remainder in each case. Okay. Friends, division is nothing but a repetition of subtraction. Okay. So first of all, let's subtract 43 from 91. We'll be getting 48. Then similarly, 183 minus 91 will be getting 3 minus 1, 2, 92. And it's 183 minus 43 will be getting 140. Now we have to find out the HCF of all of these numbers, that is 48, 92 and 140. Whatever is the HCF, that is highest common factor, that will be answer to the problem. Okay, this is what the manual method is. Now in entrance examination, definitely time is a constant. It will take some, this procedure will take some time. So let's do the problem by elimination of options. Let's see how does it happen. Suppose I have number 4, maybe number 4 is correct. So let's divide 43, 91 and 183 by 4 and get the remainder. So in this case, I am getting the remainder as 3. In this case, 88 is the last number, so still I am getting the remainder as 3. And for 183, still I am getting the remainder as 3. Okay. So 4 can be one of the choices. But we cannot be so sure since we are looking for the greatest number. That means any multiple of 4 will also exist to be HCF of all these differences. Okay, but since we are seeing there is no multiple of 4 in the options, so none other options are correct except 4. Or we can say we are looking for the HCF of 48, 92, 140, which cannot be 7, 9 or 13, as simple as that. So exactly in this problem, there is no paperwork required. Now say this case. Find the largest number which divides 238, 358 and 418, leaving the same remainder in each case. Now let's find out the difference between the terms. So it's 358 minus 238, it's actually 120. Then 418 minus 358 is equal to 60, and 418 minus 238 is equal to okay. Now we have to find out the HCF of all these three numbers. So it can be nothing else than 60. Okay, so 60 will be the right choice. Okay, friends. That means if you divide 238, 358 and 418 by 60, you will be getting the same remainder in each case. Okay, I hope you are clear with the procedure. Now let's see this problem. Which of the following is the smallest 5-digit number which when divided by 8, 11 and 24 leaves a remainder of 5 in each case? Okay, friends, in this case we are looking for a number which is multiple of all of them, that is 8, 11 and 24. Okay, Now, if we add 5 to that particular number, that is multiple of 8, 11 and 24. So whenever that particular number will be divided by any one of them, it will definitely leave a remainder of 5. Okay. So precisely we are looking for LCM of 8, 11 and 24 first of all. Then we are going to add 5 to that LCM. So whenever this number, that this complete number is divided by 8, 11 and 24, definitely it will leave a remainder of 5. But here in this case we have been asked about smallest 5-digit number. Okay, that means that particular number, that is the smallest 5-digit number, will be k times this particular LCM. Then we are going to add 5 to that. So whenever we are dividing that number, that particular number, by 8, 11 and 24, it will leave the remainder of 5. This is what the regular method. First of all, you have to find out the LCM of this. Then you have to choose a number which is of 5-digit, and then you have to add 5 to it. Okay, but we can even go for a smart technique or a short technique, which we are going to discuss now. Suppose I choose the from options. Okay, suppose I choose 1, 0, 1 to 5. So after deducting 5, it must be divisible by all of them. Okay, so 1, 0, 1 to 5 minus 5 is 1, 0, 1 to 0. Now I have to see whether 1, 0, 1 to 0 is divisible by all of them or not. Okay, now divisibility test of 24 is that the number should be divisible by both 3 and 8. Okay, now I have to see whether 1, 0, 1 to 0 is divisible by 3 or not. Okay, so it's 2 plus 1 3 and 1 4. So sum of digits is not divisible by 3, hence 1, 0, 1 to 0 is not divisible by 3. So this cannot be the right choice. Now let's see for 10061. Suppose I deduct 5 from it, I'll be getting 10056. Now let's see whether this number is divisible by 24 or not. So first of all, we check the divisibility of 3. So it is 6 plus 5, 11 and 1, 12. That means this number is divisible by 3. The last 3 digits are multiple of 8. That means this number is even divisible by 8. So this number is divisible by 3, 8 and 24, all of them as well. Now let's check for 11. It is 1 plus 6, 7 minus 5, 2. So it's okay. Since we are getting 2 not 0, that means this number is not divisible by 11. So even it can't be the right choice. Now we have two options left with us, that is 10301 and 10037. Let's check it out for 10037. If it is correct, then we don't have to go for 10301 since it is bigger than this. Or if it is not correct, then automatically this will be the final choice left with us. Okay, so let's check 10037. After deducting 5, I'll be getting 10032. Now let's see whether this number is divisible by all of them or not. The last 3 digits are multiple of 8. Definitely this number is divisible by 8. Then 3 plus 2, 5 and 1, 6. Sum of digits is divisible by 3. That means this number is divisible by 3. So this number is divisible by 8 and 3 both as well. Definitely it will be divisible by 24. Now let's check for 11. So it's 1 plus 2, 3 and 0 plus 3. That means 3 minus 3, 0. So we are getting 0. That means this number is divisible by 11. So definitely 10037 will be the right choice. No need to check 10301. I hope you are clear with the problem. Now let's see this problem. A number leaves a remainder of 61 when divided by 136. Find the remainder when the number is divided by 34. Further, dividend is equal to divisor into quotient plus remainder. Okay, so here divisor is 136. Let the quotient be x, and what the remainder is, it is 61. So we have the number as 136x plus 61. Now we have to divide this particular number by 34 and find out the remainder. So let's divide. Now we have to see whether 136 is multiple of 34 or not. Okay, so let's check 34 when we are going to get 6 at the units place if this 4 is multiplied by 4. So it's okay. So 34 fours are 136. That means we are not getting any remainder from this expression. Now we have to find out the remainder when 61 is divided by 34. That means it will be 34 twos are 68. That means it is less than 68. So what will be the remainder? That is 61 minus 34. That is 27. Okay. So this will be the correct choice. Okay, friends. Now let's see this problem. What is the largest number that divides 23, 37 and 79, leaving the same remainder in each case? First of all, we have to find out the mutual difference since division is a repetition of subtraction. So let's subtract 23 minus 23 from 37. So 37 minus 23 is 7 minus 3 4 and 3 minus 2 1. Then let's subtract 79 minus 37. It's 9 minus 7 2, 7 minus 3 4. Then 79 minus 23. It's 9 minus 3 6 and 7 minus 2 5. So we are looking for the HCF of 14, 42 and 56, and that will definitely be 14. So 14 is the correct choice. Okay, friends. Even it can be factor of 14 also, but we have been asked about the largest number. That's why it is 14 only. Okay, friends. I hope you are clear. Now let's see this problem. The least number of 5 digits which is exactly divisible by 12, 15 and 18. Okay. Now we have to find out the LCM of 12, 15 into 12, 15 and 18. Then any multiple of this LCM which is having 5 digits will be the answer to the problem. But friends, we can even go by elimination of options. Let's do it. Okay, now our answer should be multiple of 12, 15 and 18 as well. Okay, now let's see whether option A is a multiple of them or not. So option A, whether we check it whether it is divisible by 9 or not, since 18 is having 9 in it. Okay, so it's not divisible by 9 since the sum of digits is 2 only, so it cannot be the right choice. Similarly, it is 5, 6 and 7, so it cannot be the right choice. 2 and 1 3, even it won't be the right choice. So we are left with this since it is divisible by 9 and it is an even number, so definitely it will be divisible by 18. Okay, so and we are having none of these over here, so definitely it will be the right choice. No need to go for paperwork. Okay, friends. Now let's see this problem. The greatest number of 4 digits which is divisible by 15, 25, 40 and 75. Now the regular method is as such, it is you have to find out the LCM of all these numbers, that is 15, 25, 40 and 75, and your answer will be any multiple of that particular LCM. Okay, so to avoid this tedious process or lengthy process, we can even go by backward approach or by elimination of options. Definitely our answer should be multiple of 15, 25, 40 and 75. Okay, so let's check one by one. First of all, let's check 9,000. 9,000 is multiple of 15, yes or no? Definitely it is. Okay, friends, we are having 25 and 3 with us, so let's check whether all the options are divisible by 3 or not. So first option is divisible by 3, so it can be one of the choices. Okay, now 9400 is not multiple of 3, so it cannot be the right choice. 9600 is divisible by 3 since 9 plus 6 is 15 and it clears the divisibility test of 3, so it can be a choice. And it is divisible by even 25, it is divisible by 5 as well, so it is divisible by even 15, and it is divisible by 40 even, since 9600 by 40 0 0 is cancelled, last two digits are divisible by 4. That means 9600 is divisible by all of them. Okay, so even it can be a right choice. Now let's see for 9800, it's 9 plus 8 17. That means it doesn't clear the divisibility test of 3, so it cannot be the right choice. Now we are left with two options, and since we are asked about the greatest number, so greater of 2 is 9600, so it will be the correct choice. Okay friends, so even without paperwork this problem can be solved. Now let's see this problem. The least number which should be added to 2497 so that the sum is exactly divisible by 5, 6, 4 and 3. Friends, let's do this problem by elimination of options. Suppose option A is correct. So if we are going to add 3 to 2497, we'll be getting 2500. Now let's see, 2500 is divisible by all of them or not. It is divisible by 5. Yes. It is not divisible by 6 since it is not divisible by 3 because the sum of digits is not divisible by 3. So 3 cannot be the right choice. Now 2497 plus 13, it will give 2510. Now let's see whether it is divisible by 3 or not. So it is 5, 6, 7 and 8. Even it is not divisible by 3. So even 13 will not be the right choice. Now we come to 23. So the sum will be 2520. Now it is divisible by 5. It is divisible by 4 and 5, 6, 7, 8, 9. That means it is divisible by even 3. So it is divisible by all of them. So 23 will be the right choice. No paperwork is required. Okay. Now let's see this problem. The smallest number which when diminished by 7 is divisible by 12, 16, 18, 21 and 28 is. Okay. The regular method is like we have to find out the LCM of 12, 16, 18, 21 and 28. Then we have to find any multiple of that which is closer to options. Then we have to deduct. Then we have to add 7 to that LCM or a multiple of LCM to get the answer. Okay, so that process will be really tedious. So what we can do is we can go by options. Okay friends, whenever we are to eliminate the options, the divisibility test of 3, 9 and 7 is very useful. So do try to apply them whenever it is possible. Okay, now let's check from option A, that is 1008 minus 7. Okay, so it's 1001. So if 1008 is diminished by 7, we are getting 1001. Now we have to check whether this number is divisible by 12, 16, 18, 21 and 28 or not. It cannot be, since 12, 16, 18 are even numbers and this is an odd number. So it will be a wrong choice. Now let's see for 1015. Suppose I deduct 7, I'll be getting 1008. Now let's see whether this number is divisible by all of them or not. Okay. Now it is divisible by 12 since it is divisible by 4 and 3 both as well. Divisibility test of 4 is last two digits must be divisible by 4, and divisibility test of 3 is the sum of digits must be divisible by 3. So here it is divisible by 12. And let's check it for 7. So if it is divisible by 7, it will be divisible by even 28 and 21, both of them. So what is the divisibility test of 7? Just make a set of 3 numbers and find out the mutual difference. Okay, so it's 8 minus 1, 7. So 1008 is multiple of 7. Okay, now we have to check it for 16. What is the divisibility test of 16? That the last 4 digits must be divisible by 16. So we have to check it out whether 1008, the complete number, is divisible by 16 or not. Okay. Okay, so let's divide it by 16. 16 6 are 96. 4 16 3s are 48. So this number is divisible by 16. So it can be one of the choice. Or we can say, since we are getting all the conditions fulfilled by 1015 and it is the smallest among all the 3, so we are not going to check the other 2 options. 1015 will be the correct choice. Okay friends, now in this problem The least number which when increased by 5 is divisible by each one of, that is 24, 32, 36 and 54. Further, we can use the divisibility test of 9. It will be very easy for us to solve even if we go by elimination of options. Okay, now let's see. Suppose I choose the option 1 and I have to increase this number by 5. So 427 plus 5 will 432. Now I have to see whether this number is divisible by all of them or not. Okay. Now 4 plus 3, 7 and 2, 9. It is divisible by 9. Suppose I divide it by 9. I have to check whether this number is divisible by even 54 or not. That means the number should be divisible by even 27. So suppose I divide it by 9 and after that I'll divide it by 3. So if both the conditions are fulfilled, then definitely the number will be divisible by 54. So let's divide it by 9. 9 fours are 36, 7, 9 eights are 72. That means now we are getting 48. Now 48 is further divisible by 3. That means this number, that is 432, is divisible by even 54. Now we have to see whether it is divisible by 32 or not. Okay. So 432 is divided by 32. Okay. So it's 8 fours are 8 fives are 40, 3 and 8 fours are 32. So 54 by 4, 54 is not divisible by 4. That means this number, that is 427, is not divisible by 32. So it cannot be the, I'm sorry, 427 plus 5, that is 432, is not divisible by 32. So it cannot be the right choice. Now let's take 859. Now we have to add 5 to it. So 859 plus 5, that is 864. Now we have to see whether this number is divisible by all of them or not. 8 plus 6, 14 plus 4, 18. That means this number is divisible by 9. Now divided by 9. 9 nines are 81. 5 9 6 are 54. And we are getting 96, which is divisible by 3. That means this number is divisible by 54. Okay, since it is an even number and divisible by 27. Okay, now let's check whether it is divisible by 32 or not. So 864 by 32. So it's 8 fours are 8, 10 and 8 eights are. Okay, and now 108 is divisible by 4. That means this number 859 is divisible by 32 and 54. And if it is divisible by 32 and 54, definitely it is divisible by 9 and 4 both as well. So it will be divisible by 36 even. And if it is divisible by 32 even, then it will be definitely divisible by 24, since it is divisible by 8 also. Okay. So 859 is the correct choice. We don't have to check the other two options since we are asked about the least number, and even if the other two options fulfill all the conditions, then also least among all of them is 859. Okay, I hope you are clear with the method. Now let's see this problem. The least number which when divided by 12, 15, 20 and 54 leaves in each case a remainder of 8. Okay, that means we have to find out the LCM of 12, 15, 20 and 54. Then we have to add 8 to this LCM. So this will be our final answer. But let's go by elimination of options. Here we have been given a number 15. That means it is multiple of 5. Now if we go by option, let's take the first option. If we deduct 8 from 504, we'll be getting 496. Now 496 is not multiple of 15, since it is even not multiple of 5. So it won't be the right choice. Now suppose I deduct 8 from 536. Even it won't be divisible by 5. So even it is not the correct choice. I deduct 8 from 544. So I'll be getting 536, which is also not divisible by 5. Now let's go by 548. So I'll be getting 540. Since I don't have other options and we don't have none of these over here, so 548 will be definitely a correct choice. Okay friends. Now Find the least number which when divided by 16, 18, 20 and 25 leaves 4 as remainder in each case, but when divided by 7 leaves no remainder. So straightforward, just go by options. That means our answer should be multiple of 7. So straightforward, let's apply the divisibility test of 7. Just make a group of 3 numbers. So it's 0, 4 and 17. Okay. I hope you are able to recall the divisibility test of 7. Just mention it over here once again. Any number, maybe A, B, C, D, E, F. We have to make the set of 3 numbers from unit place. Now here it is DEF and ABC. Okay. Now if ABC minus DEF is multiple of 7, then the complete number is multiple of 7. So here it's 17 minus 4, that is 13, and 13 is not multiple of 7. That means this number is not multiple of 7. In this case, 18 minus 0, 0, 0, that definitely 18 is not multiple of 7, so it won't be the correct choice. Here 18 minus 2, 16, which is also not correct choice. Here 18 minus 4, this is 14. So it is divisible by 7, since that's why 18004 will be the correct choice. I hope you are clear. Now in this problem, the least number which when divided by 5, 6, 7 and 8 leaves a remainder of 3, but when divided by 9 leaves no remainder. Okay. Now straightforward, just apply the divisibility test of 9. It would, I hope it would be very simple. Now let's see 1677 whether it is divisible by 9 or not. So it's 6 plus 1 7 and 2 3 21. So it's not divisible by 9. 6 and 1 7 plus 8 15 and 3 18. It may be one of the choices. Now let's see 2 5 2 3 5 6 7 8 9 10 11 12. It is not divisible by 9. 3 3 6 plus 6 12 and 3 15. Even it is not divisible by 9. So let's not check for other numbers 5 6 7 and 8. Just we are clear that 1683 will be the correct choice. Okay. Now let's see this problem. The least number which when divided by 48, 60, 72, 108 and 140 leaves 38, 50, 62, 98 and 130 as remainders respectively is. Okay. Now friends, we can just observe that the difference between any divisor and corresponding remainder is same in all the cases. Okay. See, it is 48 minus 38, it is 10, 60 minus 50, 10, 72 minus 62, 10, 108 minus 98 is 10, and 140 minus 130 is 10. That means precisely we have to find out the LCM of all these numbers, all numbers, then we have to deduct 10 from it. Okay. So if the number is divided by 48, then we deduct 10 from it, so definitely it will leave a remainder of 38. Similarly for all other cases. Okay. So this is what the method is. Now even we can go for backward approach. We can eliminate the options. Let's see how does it happen. Now our answer must be LCM of all the numbers minus 10. That means if we add 10 to the options, it should be after that the answer should be multiple of all of them, that is 48, 60, 70, 208 and 40. Let's see whether it happens or not with the first option. Okay, suppose I add 10 to it, so I'll be getting 1 1 1 2 5. Now let's see whether this number is divisible by all of them or not. It cannot be, since it is an odd number, so it won't be divisible by 48, so it's not the right choice. Now suppose I add 10 to it, I'll be getting 1 5 1 2 0. Now let's check whether this number is divisible by all of them or not. I just take randomly the divisibility test of 9, since 72 and 108 both of them are containing 9. So let's see it is divisible by 9 or not. So 5 6 7 8 9. So as of now, let's assume it is the correct choice. Now let's take the other number. When we add 10 to it, I'll be getting 15130. So it's 5, 6, 7, 8, 9, 10. So it is not divisible by 9, so it cannot be the correct choice. Now let's say this 15210 plus 10. So it's 15220. So it's 5, 6, 7, 8, 9, 10. Even it cannot be multiple of 9. So do not look at the other numbers and options. It is the correct choice. Okay, friends. I hope you find the method very simple and even no paperwork is required. Okay. Now let's see this problem. Find the least multiple of 23 which when divided by 18, 21 and 24 leaves remainders 7, 10 and 13 respectively. Friends, as in previous problem, further we just observe over here that the difference between any divisor and the corresponding remainder is the same. And here in this case it is 11. That means 18 minus 7, 11, 21 minus 10, 11 and 24 minus 13, 11. That means our answer will be, just a moment, it will be LCM of all these number minus 11. Okay. Now, as we have already done in the previous question, we can go by backward approach or by elimination of options. Okay, friends. Friends, simultaneously this number should be multiple of even 23 as we have been asked in the question. Now let's go backward. Suppose 3002 is the correct choice. That means this particular number 3002 is actually LCM minus 11. So suppose I add 11 to this number, it should be multiple of all of them. So 3002 plus 11 is 3013. Now we have to check whether 30123 is multiple of 18, 21 and 24 or not. It cannot be since it is an odd number. Okay. Now just add 11 to this. So 3013 plus 11 is 3024. Now let's see whether it is multiple of 18 or not. It is an even number, so it will be multiple of 2. Now let's see for 9. 4 plus 2, 6 plus 3, 9. So it is divisible by 9 and 2 both as well, so it will be divisible by 18. And since it is divisible by 9, it will be definitely divisible by 3. Now let's check for 7. So just make a group of 3 numbers. Here it is 0, 2, 4. Deduct this, that is 3. So 24 minus 3, we are getting 21. Definitely the number is divisible by 7. So 3024 is divisible by all of them, that is 18, 21 and 24. Okay, so it can be the right choice. Okay. Now we have to see that 3013 is multiple of 23 or not. Okay, so divide 3013 by 23. So it's 23, 1, 7, 23, 3s are 69, then 2 and 3. Okay, so it's 131. So it is divisible by even 23. So it will be the right choice. Do not look at the other options. Okay, friends. I hope you are clear with the solution. Now let's see this problem. The largest 4-digit number which when divided by 4, 7 or 13 leaves a remainder of 3 in each case. That means we have to first of all find out the LCM of 4, 7 and 13. Then we have to find out any multiple of this LCM which takes us to a 4-digit number. Then we have to add 3 to that. Okay, so this is our final answer. Now as usual we can go by even backward approach to reduce the time and to avoid the paperwork. Now let's see, suppose 8739 is the correct answer. That means 8739, if it is divided by 4, it will leave the remainder as 3. That means this particular number, that is 8739, if I deduct 3 from it, it should be divisible by all of them. So let's see, 8739 minus 3 is 8736. Now let's see whether it is divisible by all of them or not. It is divisible by 4 since the last 2 digits are divisible by 4. Now let's see for 7 and 13. The divisibility test of 7 and 13 is same. deduct this number from the set of this three number, that is 736 minus 8, that is 728. Now 728 is divisible by 7, and 728, if it is even it is divisible by 13. Okay, so it may be the correct choice. Now let's see the other cases. Suppose I take 9831, so I would just deduct 3 from it, so it's 9828. Okay, now let's see it is divisible by all of them or not. So 28 last two digits, that means it is divisible by 4. Then 98 is a multiple of 7, or we can say 7 into 14 is 98, and even 28 is multiple of 7, so it will be multiple of 7 also. Now let's see for 13. You can even apply the divisibility test. 828 minus 9, that will be 819. So 13 6 are 78, 3 and 9, 13 3s are 39. So it is divisible by all of them. So it will be a better choice since we are asked the largest 4-digit number, and this number, that is 9831, is bigger than this, and it is fulfilling all the conditions. Okay. Now there is only a difference of 3 between these two, so it cannot be right choice. Since it is fulfilling all the conditions, it cannot. Now let's see for 9893. If I deduct 3 from it, I'll be getting 9890. Now the last two digits are 90, which are not divisible by 4. So this number 9890 is not divisible by 4. So it cannot be the correct choice. So we are left with this. Okay. I hope you are clear. Friends, we have done more than 100 problems on this HCF, LCM and divisibility concept. I hope you are solving the problems along with me, and you are finding yourself comfortable now. Okay, now we'll be doing some applications of HCF and LCM with some word problems in our next session. Okay, by then do revise the concepts, and all the best.